So let 1 plus I is equal to r into cos theta plus I sin theta. Cos theta plus I sin theta. So what we have to do here is we need to get the value of r and theta. Okay. Now just open this one, that is equal to r cos theta plus I into r sin theta. So of course you can avoid this step, directly you can write this step, but I am going to write now. So equating the real and imaginary parts. Equating real and imaginary parts on both sides. So what you will get here, real part is 1, here real part is r cos theta. Real part means where there is no I, imaginary part means where there is I. So real part is here r cos theta equal to 1, you will get, we'll take it as equation number 1. Then imaginary part is r sin theta, means here I r sin theta, here I into, actually it is I into 1. Okay, so here the coefficient is 1. So r sin theta is 1, not I. So do not take it as r sin theta is I. You are taking just the coefficients of I. So here r sin theta and here I into 1 is there. So even though we are not writing, it means that 1 is there. So it is 1. Now this is equation number 2. Now squaring and adding. So 1 square plus 2 square. So when you square this equation number 1, it is r square cos square theta and right side will be equal to 1 square. Equation number 1 is r square cos square theta equal to 1 square. Equation number 2 is r square sin square theta and here it is 1 square. Okay, so we squared both and then now we are adding them. So squaring and adding them. So now if you look at this one, r square into what you are getting here, it is cos square theta plus sin square theta equal to 1 square plus 1 square is 2. Therefore, now we know cos square theta plus sin square theta is 1. Okay, so that is r square is equal to 2 or r is equal to, actually plus or minus root 2 is there, but this r being the modulus, length of that complex number, we'll take only the positive value. So r equal to root 2. Okay, now we need to get theta. So what we are doing is we are finding r and theta and substituting here. So to get the value of theta, what we do here is equation number 2 divided by 1. So equation number 2 is r sin theta, this, divided by equation number 2 is r cos theta, this is equal to 1 upon 1. 1 upon 1. So therefore r sin theta by r cos theta, we are getting it as tan theta. So tan theta equal to 1, therefore theta means tan inverse 1. Value of tan, value of theta for which it is 1. So it will be pi by 4, tan 45 is 1. Okay, so we got theta also. And here also there are some conditions to take this theta and all. Now I am not going deep into that. Here both these are positive. So the value of theta will come in the first quadrant. So we are having here pi by 4. Therefore 1 plus I is equal to r into, r means root 2 into cos theta pi by 4 plus I sin pi by 4. This is the modulus amplitude form. Okay. Now the same thing we can write as, this is root 2 into, so if you write, we know cos theta plus I sin theta is e raised to I theta. Okay. So already we have written that is cos theta plus I sin theta is equal to e raised to I theta. So if I use that here, if I use this here, this will be here theta is pi by 4. We can write this as e raised to I pi by 4. Okay, so root 2 into e raised to I pi by 4 is a simple notation of 1 plus I. Okay, now suppose for another example, say we have, if I write say root 3 into e raised to I pi by, or say if I want to write root 3 into say cos pi by 3 plus I sin pi by 3. If I have like this, then this will be equal to root 3 into e raised to I pi by 3. Okay, theta is pi by 3 here, so we can write it as e raised to I pi by 3. So like that we can write simultaneously, we can write that as a polar form and the exponential form. This is very useful in solving the problems.